The J-50 J-XDS, a next-generation stealth fighter under development by China, represents an ambitious attempt to close the technological gap with American and Allied 5th and 6th generation aircraft. However, despite its futuristic appearance and the national prestige attached to it, there are numerous and significant disadvantages associated with this aircraft that raise questions about its actual performance, reliability, and strategic value. From a design standpoint, the J-50 adopts a tailless, delta lambda wing configuration with advanced shaping intended to enhance stealth. However, this radical departure from conventional designs introduces structural and aerodynamic complexities. The use of movable wingtips as control surfaces, a feature not commonly seen in operational fighters, adds mechanical complication and may pose reliability issues over time. These moving parts also create seams and gaps that potentially degrade the radar stealth signature, particularly under high stress or after sustained wear and tear in operational conditions. Internally, the aircraft is assumed to carry all of its weapons in internal bays to preserve low observability. While this design is effective in reducing radar cross-section, it imposes serious limitations on payload capacity and mission versatility. External weapons carriage would compromise its stealth, meaning that in high-threat environments, the J-50 is effectively limited to a smaller set of munitions and fewer operational roles than legacy or multi-role aircraft. Another critical disadvantage lies in the propulsion system. If the J-50 uses China's new generation WS-15 engines or derivatives, these have historically faced serious hurdles in achieving the necessary thrust, reliability, and thermal efficiency for sustained high-performance flight. Even with thrust vectoring capabilities, these engines could produce a larger infrared signature, making the aircraft more vulnerable to heat-seeking missiles or advanced IRST, infrared search and track, systems increasingly deployed by adversaries. Furthermore, immature engine design increases the risk of mechanical failure, high maintenance burden, and reduced sortie generation rates. The complexity of stealth maintenance cannot be overstated. Coatings and composite materials designed to absorb radar are sensitive to heat, weather, and abrasion. In high-tempo operational environments, aircraft like the J-50 would require long downtime for inspection and reapplication of stealth coatings. This not only increases lifecycle costs but also limits operational readiness during conflicts, especially when rapid deployment and sustained combat sorties are required. Beyond the physical aircraft, the technological ecosystem surrounding the J-50 introduces further disadvantages. An advanced stealth fighter relies not just on airframe design but on a tightly integrated suite of avionics, sensor fusion, electronic warfare capabilities, secure data links, and battlefield networks. While China has made significant progress in areas like AESA radar and electronic warfare, its systems have not been tested in real combat environments, and their effectiveness remains uncertain. Moreover, integration with ground-based command networks, airborne early warning systems, and satellites may still lag behind Western standards, limiting the J-50's ability to function as part of a true network-centric warfare framework. Cybersecurity and software resilience are also critical concerns. Modern stealth fighters are heavily software-defined. Without rigorous and transparent testing, there is a risk of vulnerabilities in avionics, mission systems, or even flight control software. If these systems are not robust, the aircraft could be susceptible to cyber interference or battlefield malfunctions. Then there is the issue of training, logistics, and operational infrastructure. Advanced aircraft like the J-50 demand a highly trained pool of pilots, ground crews, and engineers capable of maintaining complex systems under pressure. Whether China currently has the human capital and technical support infrastructure to sustain a fleet of J-50s in high-intensity operations remains an open question. Without it, even the most advanced aircraft can become a liability rather than an asset. In parallel to these technical limitations, the role of Chinese propaganda in shaping perceptions of the J-50 cannot be ignored. Official state media and affiliated analysts often make bold claims regarding the J-50's capabilities, such as calling it a sixth-generation fighter or stating it surpasses the F-22 and F-35 in stealth and performance. These declarations are typically not accompanied by technical data, independent verification, or even detailed specifications. Instead, much of what the world sees comes through carefully curated imagery, animated renderings, or promotional videos designed more for strategic messaging than transparency. This messaging is part of a broader narrative intended to signal technological parity with, or superiority over, the United States. However, in the absence of third-party evaluations, combat exercises, or even data shared with allies, these claims remain speculative at best. Moreover, this constant reinforcement of the J-50 as a game-changing weapon may create risks internally within the Chinese defense apparatus. Military and political leadership may begin to accept exaggerated assessments as fact, leading to overconfidence in planning and decision-making, especially in a high-stakes confrontation. In wartime, such assumptions could have grave consequences. Overestimating the J-50's survivability or overlying on its presumed stealth and avionics could result in mission failures, strategic miscalculations, and greater vulnerability to enemy countermeasures. Meanwhile, potential adversaries, aware of the performance gaps behind the propaganda, may already be developing specific tactics or technologies to exploit its weaknesses. While the J-50 J-XDS is presented as a cutting-edge leap forward in Chinese airpower, its real-world limitations are numerous. These include unproven stealth claims, complex and potentially fragile design features, uncertain engine reliability, limited payload and operational flexibility, insufficient training and logistics systems, and an overhyped image crafted through controlled media narratives. Until the aircraft is tested in real combat or international joint exercises, much of what is claimed about the J-50 remains speculative, and its strategic value more symbolic than substantive.